Hi, my name's Michael Crawford. I'm your training instructor for this demonstration. Today we're going to cover bolted connections. So in this video we're going to cover in great detail how bolted connections are created. I must admit that bolted connections can be quite complex or they can be quite simple. It just depends on what you want to achieve. In most cases our bolted connections use equations. If you're not familiar with equations, I suggest you learn how to provide and produce equations in your components and assemblies. Get a really good understanding of why they do what they do and how you can manipulate things with equations. Usually for us, equations will turn things on and off, or they will create patterns and drive patterns, especially for fasteners and the like. So we're going to go into great detail of how a connection is created, but first of all I'm just going to go over a bolted connection and make sure that you've got a pretty good understanding of what a bolted connection is. So I've got a basic layout model here that I've been playing around with. I'm just going to go in and show you how a bolted connection works. So at the moment we've got one bolted connection here. If you want to delete a bolted connection, just simply use our tool because it'll clean up the file as well as the database behind and all the data that's involved in it. Sometimes the bolted connection may not remove the holes. The cavity might fall over. Just go in and delete the feature. So I'm going to insert a bolted connection from our library. Each country has its own bolted connection standards. So I'm just going to grab ours. You can see that I've already used that bolted connection, and I'm going to select this bolted connection here. So in this case it tells me to select the beam first, then the column. The first item usually when we insert is the welded to member component. The intersection point is the sketch point at which the two sketches attach to one another, and those two attachment sketches form that intersection point. What will happen is when we create the connection, it will put a 3D sketch point in at the welded to member, which is this one, in its assembly, and it will bolt to it. Now for a bolted connection to work, we must have a welded member and a welded member. They can't be section and section because it's got nowhere to put the connection. It can't be a section and a welded member or a welded member and a section. So they must be two welded members in order to place the connection. We can have as many as up to 4 bolted members in our connection. If you've got more than that, it's recommended to create another connection and insert that connection over the top. Right now, this connection is by default going to mate the connection to the front face of the item that it's going to be welded to. So in this case, because we draw all of our beams from left to right, and the top face is the face that's pointing towards the right on this side. So by default we'll leave that as it is, and you can see that I've selected and the colors match what I've selected. Now if I hit my tick and put that in, so to put in a bolted connection that automatically updates the number of bolts, as I mentioned previously, you must understand equations in SolidWorks, and that way the bolts will automatically pattern and the holes would automatically pattern. So let's go down into detail of this connection. But before I do, you've got to ask yourself whether or not you need a bolted connection, or this is going to be a one-off and you probably will never use it ever again. And if you get one of those scenarios, you can actually build up your welded member with plates. Sure. If you do that, then there are consequences to doing that. In our bolted connections, they're simple. They can be complex and they can be simple at the same time. It just depends on what level you want to go. In this case, this connection automatically updates as we insert it based on its welded member. So with this connection, we're going to open it, and you'll notice that by selecting a plate, it's exposed the tree, and in the tree we can see that that's the connection. And if I go up even higher in the tree, you can see that this is the welded member beam to which it's been welded to. If I open up the welded member beam, you can see inside here the connection resides. These components are envelope components, and the plate is attached to that as the connection sits inside the welded member. Now if you cannot select anything, that's okay. Basically, it's a simple suppress, click save, and then unsuppress, and now I should be able to select. This happens from time to time due to the level of the connection as it's been inserted being dragged from the top level down into the welded member assembly. Now you'll also notice that due to the connection being placed in here, a sketch point has been inserted into the project at which the 2 points that we selected when we inserted the connection have coincided. And that's a reference point that's linked to the connection above, to the driving sketch above. So if we were to change the driving sketch, this connection would move with it. And of course, because the beam is also attached, the connection and the beam would move if we moved either one of them. And that maintains our parametric behavior. So our connection, when we inserted it, automatically created the mates and locked this connection in place so that it can't move and it's fully defined. It's also grabbed the 2 attachment sketches based on the sections that I selected. So the first attachment sketch was the welder 2 member, and the second attachment sketch is the column. So you can see that those 2 attachment sketches are in place and they've been attached, and they have a reference. So that little arrow at the end tells us that that is referenced to something. So if I was to have a look at the external reference, it'll tell me that it's attached to the beam at this stage. Okay. Now the connection itself, I can tell that it's an end plate connection, and it belongs to beam 4 just by looking at the file name. Obviously I've got beam 4 open, and I know that it's the connection 1 in the connections of the file. If I go to open up the welded member, you'll see that there's a folder that's been created, and that folder contains all the items related to that connection, including the drawings. Let's have a look at the connection as it stands by itself. So we have 2 sections in here, and both of those sections are enveloped sections because we want our envelopes to disappear at some stage. We have a tool in here that allows us to hide our envelopes and show our envelopes. When you click them, they disappear, and when you show them, they come back. These sections are utilized to spatially constrain our plates at our connection point. So if we were to insert this connection on a column, this column section will automatically update, and our beam will automatically update, and the plate itself is also attached to the beam, so that depending on what the beam's depth is, the plate will automatically update. Now let's have a look at what's been put into this connection. So obviously we've got our 2 attachment sketches. So the very first attachment sketch is simple and is just like all the other attachment sketches within our application. The attachment sketch is the first sketch line and the only sketch line, and it's drawn from the origin away from the origin. In this case, the columns sketch line is drawn from the bottom to the top, and this is where we talked about driving sketches and maintaining a direction to which we keep as a consistent direction of sketching. So when we insert this connection, those attachment sketch segments are related to the driving sketch that holds both the welded members for the column and for the beam, and that locks it in place. Now let's have a look at what's going on with our sections. So the first section is our welded member section. Sometimes you might have them back to front. It just depends on how the connection was created. So our first section that has been inserted into our project has a structural member that we've called welded. This is how, when we insert the model into insert the connection into our project, this is how it's found, so that it updates this section to match that section that we've selected as the welded member. And likewise down below, the next section being the bolted 1 member, and obviously bolted 1 is the name of the section for our first bolted member. So those 2 sections features are found in the process, and when we insert the connection, they are updated to match the sections that we've selected in the interface to insert the connection. Okay, so moving along, we have a plate. Now we're a little bit different in how we do our plates. It's up to you and how you want to do your plates. But for us, we've actually gone down and we've driven the plate by using a sketch in the assembly. So if we ever go to the connection, we know that there's always a sketch that drives our plate. That sketch sits in behind and it drives the plate's position for the holes. It drives the plate's depth based on its offsets, and you can see here we've got our 6mm for our welds, and this is obviously a driven dimension. And we've also got an equation driven set down here that we can change. It's more than likely that this is a custom property. However, you don't need to do this if you don't want to, but it's included in our equations so that it can help us work out what our patterns are for our bolts. You'll notice that inside the plate we've actually called it welded, so we know that that plate is going to be attached to the welded member. It's not necessary to do that, but we did that anyway. And that doesn't always apply to all of our connections, and that name doesn't really mean anything apart from the fact that we know that it's being welded. Most of our plates that go into connections have to go to the welded plate because that's the member that is going to be inserted upon. Then we've got our patterns. We've got two different patterns. So we've got a cut, which is our holes, and then we've got our linear pattern for our holes and our bolts. These all are driven by sketches that we have at the top. So let's have a look at those. So obviously we've got our driving sketch for our plate, and you can see that that's just sitting back a little, and we have our plate and its size determined by that sketch. So this sketch at driving sketch level drives the sketch in the plate. So if we want to change the plate, we go down to the driving sketch. Some people prefer it so that if they do double click on the plate, it gives you all the dimensions. For us, I've made the decision for connections, in my particular case, to drive them through a driving sketch. The next sketch is a welded cut. Now a welded cut is a cut that will cut the welded member, and you can see here at the point at which the origin resides for our connection, it's trimming it back to the other side of this plate so that when we insert it, it will trim this beam back. The welded cut name is the item to which the application looks for. Steel Designer Pro will cut that section based on that welded cut. And of course, if we wanted to cut back the bolted cut, we put bolted 1 cut in there, and that will cut back the bolted 1, or bolted 2, or bolted 3, and likewise for all the others. Next, we've got our holes. So we've also created a holes sketch, which is coming from our driving sketch. So the holes sketch is just the top 2 holes, and then we've punched the holes through. And then we've created a hole pattern. If you double click on the hole pattern, you can see the hole pattern is linked to our equations. The hole pattern is based on the overall length in the equations. And then we've created a derived pattern from the hole pattern to place the fasteners. The fasteners in our project, or in our connection, are the only top 2 ones. So they are patterned to match the holes based on that derived pattern from the holes pattern. Let's have a look at the equations later, but first I want to cover holes and how holes are created. Holes are created via an in-context cavity, or a cavity that spans across multiple items to create that cut. A cavity, if you're not familiar with, subtracts one body from another, and it does it through parts. So if you've got solids in your parts, it will allow you to do that. So in this case, if I was to turn on my solids, which I've turned off in my solid bodies, you can see that they've been turned off, and the code does that automatically. If I show them, you can see that they are solids that are pretty much converted from the face of the plate through and extended out. Now you can make these any way, shape or form. We have a tool called Match Holes. If you select this side of the face and that side of the face, it will put the holes in for you based on the holes in the plate, and it will hide the bodies. The cavity that is created into the section at this point, and there's no cavity, but the connection will create a cavity in the column section for you. sometimes you don't need to in your dummy components put the cavity in. Sometimes we do, just to see how it will operate, but it's not necessarily required in your dummy component, envelope component sections. Okay, so holes are created, I'll go back to that, sorry. Holes are created by an intersection of the back end face of the plate. So if I was to edit that sketch, you'll see that the holes are matching the holes in the plate. So how that's done is simply just as simple as going, let's convert the entities and change that to intersection curve. Okay, and what we do is we then select this face. So let's just go through the process and I'll show you how it works. We may have some things drop off, but creating holes is quite simple in the fact that it's just as simple as converting sketch entities and then through an intersection curve and then deleting the outside perimeter. It means that when the holes change in their pattern, it will automatically collect any new entities, whereas convert entities does not do that. An intersection curve does. So what we do is we start a sketch on this face. We then under there go intersection curve. Now before you go intersection curve, we need to select the body that we're going to intersect because it's on that face. So you know that that's the face that's going to be intersected curved. Okay, so we've selected the part. We then go into intersection curve. I don't know why my intersection curve is not coming up. Oh, there it is, it's done it. Unselect my filter and you can see through the intersection curve it's selected the outside boundary. So if I was to go select chain and go delete, the only new entities that will pop up are now based on if I cut the plate or if I add new holes. So now I have done that. It's just as simple as going, let's create a boss extrude through the other side, and we will give it, say, 100 mil. And there is my hole component. Now if I wanted to hide the bodies, you just click on here and go hide, and that gets rid of the bodies. So the bodies are there, they're inside, and they're used for cutting the welded member. Now you'll notice that the holes also had a name in them so that they knew which component to cut. So in this particular case, that feature should be called, in this case it's bolted 1 cut, so in capitals bolted 1, and that's all you need to put in there, bolted 1. So now when the application inserts the connection, it knows which holes need to cut which section. So you can cut welded members, you can cut bolted members, you can do all sorts of things around just through naming to get where you need to go. That pretty much is the connections overview and how a connection is formed and the requirements for the connection. The plate itself, as you can see, if I was to open the plate up, it is drawn on top plane and the drawing associated to that is underlying. Connections can be quite complicated. It depends on what you want to achieve. So now let's look at equations. This, if it's foreign to you, that's okay. You should go and learn how to create equations, how equations are going to influence your connections, and get a really good idea on how an equation system will work for you. In this case, because I'm a developer, I understand formulas, I understand how the equations work nicely. This is how we can drive things. You can see at the top we've collected the overall driving sketch of a sketch called driving sketch, which is this one down here, and we've collected the overall dimension for that, and we've called it D. So that's read only. And then we've got the centers that we want to add, and then we've got the hole center. So THE is the top flange hole. So if you look at the comments that we've got over here, it's the top flange hole. And then we've got our hole centers, and these are linked to the patterns and dimensions, as you can see. We also have a minimum edge requirement. Obviously, if your bolts increase to something extravagant, you need to change that depending on your standard. And then we've got a formula using an int where we subtract from the overall height, the top edge, and the minimum edge, and then dividing it by the number of hole centers distance, and we've increased it by 1 to allow for the calculation to occur so that it gives us a total of 3. That's our hole number. Then we've got a bottom edge flange distance that we need to calculate, and that's come up as 53. We've also got a hole pattern based on the number of 3, and we've linked that as well. And we also have the bolted beam depth collected, and we also have the bolted flange bottom depth collected as well. There are different reasons for collecting bits and pieces of information, and they can be used so that it'll drive your connection for you. So when we use the equations, we're able to automatically, once this section changes, update the number of fasteners, the number of holes, and the number of hole cutting cavity bodies. So now we're going to create a connection from scratch to show you how the basics works. I'm going to go through that in great detail. Apart from putting in the equations, because the equations can take time, but I'm just going to show you how to create a basic connection that's going to punch 2 holes into the end of a beam and be an end plate in a project. So I'm just going to get out of that and close it. If you want to delete a connection, you cannot do it at the welded member level. You need to be at the zone level. So we go to connections, delete. And in this case, it's remove the holes. Okay, so now we're going to put in a new connection, and we're going to put it in at this spot for us to work with. So if I go connections and I go new, it's going to be an end plate. So we select which one we want. We select a blank connection to work with. We're going to select the insertion point, and at this particular stage we don't really have anything to connect to, but it's good practice to always just select what you're going to insert your connection onto, and then hit my tick. Okay, we now have a connection in this beam. There it is there. Let's open it up. There's our connection. It's got nothing in it at all. We have one attachment sketch. If we look at where the origin is, we can see that the attachment sketch is obviously in the beam's direction and it's already related. However, it's not fully locked. So we'll just put a dimension on it to lock it. I'm going to create another attachment sketch, and I'm going to use the front plane for the column. So this column continues through, so all I'm going to do is just give it 100 mil above. You can give it any dimension you like, and then I'm just going to make this one say 400. That's an attachment sketch, so I'm just going to grab that and drag it up to here, and hopefully it does that without any hiccup. Attachment sketch 2. So now we've got 2 attachment sketches. We also have inside of here a section. The section that's already been applied is attached to the very first attachment sketch. So we can go in, and this is going to be our welded member. So I'm going to put a welded member section in here. Turn on your weldments, grab a structural member, and in this case I'm going to grab something that reflects what we're modeling to. So in this case it's going to be a 310, and I'm going to set that down. Okay, this is a section. Okay, so what we're going to do now, it's already an enveloped component that's already been added. We don't need the Steel Designer data link, so I've just deleted that out of there. You can't delete it out of the section when you're in the section, you have to delete it out of the assembly. If you go back in there and then click save, it'll put the data link back in. We don't need it, so I've taken it out. It doesn't fire anything and it's not used for any data at all. So that's how we create a part that's already got a sketch segment in it for an attachment sketch. Alternatively, we then can go to our parts and grab a section and insert a section into our connection by selecting the section, selecting the sketch segment we're going to insert it on. We want to make it an envelope so that when it puts it in, it becomes an envelope, and we're going to use the center location point. So this will put the section in place, and now you can see that this section is quite large. I'm going to make it something that is easy to modify. So it was a WB originally that I've selected, so I'm just going to put in a UB, and I'm going to make it 310 as well. Hit my tick and update that. Okay, that also has inside of it a data link. I don't need that as well. And now you can see that because my beams are pretty close to one another, I'm just going to double check, change the dimension on this and make it a bit deeper so that the connection looks a little bit more realistic. Okay, at this point we can add a sketch in the top level assembly like I have with the previous connection, but in this case I'm just going to do a very simple connection that can be updated based on your own manual input rather than having it fully automated. So in this case I'm just going to go to parts. I'm going to grab a plate. There's a plate, a simple plate. That plate is just got 4 holes on the end of it. I'm not going to go overboard. I'm just going to use a stock standard 4 plate. So that's a stock standard 4 plate. We're going to insert that as per standard, but we want to insert it at the origin, and then by default it inserts it at the origin. We're going to unfloat it. It fixes it. We need to work out which orientation this plate is going. So if you look at it, by default the plate's plane is at the bottom, so I'm going to make that to that face. If you don't get it rotating the right way, we can flip it, and then we can align this plate the way we need it to. So in this case I've got a plane here from remnants. I'll just remove it and I'll show you what I did. So if you select the top face and the top face of this section and go to insert reference geometry plane, it will pull the center plane in. So I'm using the center plane to position my plate. So in this case that and that, those front and the front plane of the plate and the plane that I've just inserted being the divider of the section's 2 faces, I'm then going to relate that. It's best that you use a plane to do that, not the sketch, because if the section changes, the sketch changes its entities, and it could lose the relationship to the sketch associated to that welded member. Hence the reason, to that weldment profile. Hence the reason that I've put in a bisecting plate between the 2 flanges. So now we're going to lock this plate in place. Now we've got it on 2 faces. If we select the right face and the front plane, we should be able to lock those in place. Looks like we've got ourselves an over-defined situation here. So we've got an angle here that isn't liked, and we've got an angle here. So what I'll do is I'll just remove one of these angles and see what happens. Nope, that didn't fix it. I'll remove the other angle. That fixed it. So SolidWorks for some reason doesn't like the angle mates in place. So I've just removed them all together, and that's locked the whole connection in place now. We just need to make sure that our sections are going to be able to operate when they change without falling over. So in this case the plate is locking these 2 together. So just be mindful that that might fall over. Usually we try to isolate these items so that they don't work together. If we go to our tools, we're going to trim this back so that this plate can be trimmed back. So we're going to use trim part. So you select the section you're going to trim, which is this one, select the face to which you're going to trim against, and then hit the tick, and that should trim it back. If you get the opposite sided trim occurring like we have here, it means that you need to go into the weldment profile. This happens from time to time. It's because SolidWorks doesn't know which one to remove, so we've actually got to edit the body and switch the trim. In our code we've added it so that it knows which one to take, but sometimes it doesn't work. So we've selected that, and now our trim has been applied to our section to do that. So this is starting to look like a connection that we could utilize. I'm going to make some changes to the dimensions. Let's just make this say 75, make that 150. We want to drive the plate so that if we do change the section, the plate will move with it. Plus we want to set it up so that it does its welds. So I'm just going to go in and edit the sketch associated to it, make this driven, switch that up, and give it a 6mm setback for a fillet weld down the sides. So that plate now will be completely driven because it's centrally mated and it's centrally distributed at 6mm either side of the beam. Now the next thing we need to do is add holes. So holes can be inserted manually or they can be inserted using our hole match holes tool. So if you select this face and that face and then hit your tick, that'll put the holes in for us. So it's dropped in a component for our holes, and you can see this is the component, and you can see that it's called it bolted 1 because it's picked up the fact that the component has attached itself to the bolted 1 back end feature automatically. You need to make sure that that is correct. Okay, so there's our holes. Now we're going to put in our fasteners. So if we go up and go to parts, fasteners, select this face and that face, select the fastener that you wish to use. In this case I'm just using the stock standard fastener. I'm metric based and I'm going to use an M20 and I'm going to make it so that they are plain. And hit my tick. Now in the one instance of me inserting these, it's put 4 of the same fasteners into the project, and there they are. If I was to modify any one of these fasteners, you would notice that all of them change because they are the same component. Now our fastener, because we selected the back face, has had the grip attached to the back face as a plane, as an offset for that fastener. So if the thickness changes by any means or needs an update, the grip length gets thicker because the grip length gets extended because the ply changes. These bolts automatically update when we insert the connection. So be mindful that happens automatically for us so we don't have to worry about it. The plate itself, I usually open the plate up, save it, and then open up the drawing and make sure that the drawing is okay for us to add the connection to the library. So we're right to go as far as I can see. Our connection is ready. Now, are there any cuts that we should apply? Yep, there should be. There's one cut that we've forgotten to apply that needs to go into this, so we need to put that cut in now. And that's to cut back our beam. So if we go to our front plane, put a sketch on it from the origin, and then you can set this up so that that edge and this edge align, and this edge of the back plate, because it's going to trim back to that, and that are collinear. So we've added our sketch. Now we're going to call this bolted 1 or welded 1. Which one is it? It's welded. There's only ever one welded item in a connection, so that means that it's going to have to be welded. If another item happens to be welded as well, we just call that bolted 1, and that way we can isolate the two of them. So the naming sequence of these items, that should be called welded cut, because we're going to do a cut, right? That's the name of the sketch feature that's going to do the cutting. And I usually hide my sketches so that you can't see them, so we want to make sure that all of our sketches are hidden. Now you can use our hiding sketch mechanism. I'm just because there's only a couple. Our hiding sketch feature, which is here under hide sketches, but I've just had a couple to change. So now our connection is ready for us to upload to the library and test. So if we go to connections and go to library manager, this is how we add items to the library. So adding items to the library, it knows that this is a connection by default. If I was to select this feature in any of the welded or parts or even the projects, it will automatically know that this is a connection that I'm going to add. So in here, we know that this is going to be an end connection, but if we needed to create a new library filter to store it, we would click on the connections filter, and that now has filtered it out. So we've got all of our connections in here in our library manager, and then we can go to our filters, and if we wanted to add a new filter to store our library item in there, we would go add. Same applies for every other library model except for parts. Parts, you cannot add a new library filter. These are fixed. Connections, you can. Welded members, you can. Zones, you can. And projects are not existent at this stage. still in development and will come later. If we click on the connections and we go add, this is an Australian standard. This is an end plate connection. Its default mating relationship is front plane to front plane. However, we can change that if we need to later. So if you wanted to, you can change this image so that when the snapshot comes in, it'll be white in the background. So let's do that. So if you right mouse click, edit scene, take the image away, click none, and that is that. Now there are other things too. If you go back to edit scene, you might want to take away the floor shadows and the floor reflections so that they don't show up as well. Save it. Now we can add it to the library. So we go back to the connections, library manager, add, and you can see that that image did not change for us. For some particular reason it should have been white. Gene knows how to do these things. If you want to ask Gene or Will, both the same guy, he'll tell you that to change the image in the background, you can do that through a macro that he has created. Then we click Australian, and again, and we click add. So that closes off our project and then adds it to the library. So now it's in the library. So if you click on connections and you go end and scroll down, you'll see that our connection has now become part of the library. Let's open our project back up again and test our connection. So this is our zone in our project. There's our connection. So I'm going to either copy the connection or delete the connection to test it. I like putting it in the library, testing it in the library, and then inserting it. You may want to just copy it from one location to the other to test it. Either way is fine. Now it tells me that it's locked. I can't remove the folder for some particular reason. This sometimes pops up. So now that that model has been removed, just make sure that the remnants are gone. Sometimes they don't go. So that I've just removed the two attachment sketches that are in here. That's probably why it didn't allow me to relieve it from being removed from the system. So let's go back into the project. You can simply just open it up through this method because we're already in that model. Let's open up the beam that we're in, and let's see if we can delete the connections files. So that's the connection that we had in there, and it's gone now. Make sure you clean up your mess as you go. If it doesn't do it for you, it should, but sometimes SolidWorks does tend to hang on to some files and it won't let you delete them, so you just got to go in there and manually do that. It doesn't happen all the time. So let's go to our end connections, select our end connection that we've added to the library. There it is, click use, and now we're going to test it to see if it works. So obviously the first one's this one and then that one, and hit my tick. So now that connection has been inserted, we'll just do a quick check to make sure everything's okay. See if the holes have been added. Yes, they've been applied. The trim has been added to the section so that if the section changes the depth, and the section cut would apply. The plate has been still attached, so we know that if the depth of the section changes, that plate will automatically update. The bolt has adjusted itself to match the change in the section to which it's been inserted onto. So that pretty much covers how bolted connections can work. That's a very simple bolted connection. We will do more advanced bolted connections in a later tutorial to cover pretty much how the equations work and all the fasteners and obviously different fasteners for different plates and for different sections, for different connections that have multiple attachments or multiple sections. If you've got any questions, please feel free to send us an email at support@cadcraftsman.com. We'd be happy to help, and thank you for watching this demonstration, and we look forward to seeing you in the next training session.